Hi all, Mads Barnkop from Kaizer Power Electronics. Today I'm here with this EMC2 power supply from the PowerEdge M1000E Dell server. This was a modular power supply used in the backbone switches and also the smaller blade servers. It is a 12 volt DC 22 amp output power supply. Has a nice little fan sitting here. Other than that, it just seems to be a power supply module. Has a connector down here. And looking through the grating here, can actually see it's marked L and N for phase and neutral. This seems to be ground. Has some control pins, and we have the negative and positive lead out, assuming that the negative lead is the longest to make connection first. That is pretty normal with server power supplies. Also has what appears to be a 5-pin port here. Seems to be a crystal in there, so that could be some kind of programming port. Maybe it can be adjusted with a PC. Now the Dell product number, we have that here. That's 071 000 462. But this power supply is known as the API4SG10. We can see up here the L and N mark. We have the input filtering. We have the rectifier bridge sitting under here somewhere. We have the bulk DC capacitance. Then it is probably made up in a PFC stage and a output stage. And we can actually see from the size of the magnetics, the transformer, output transformer here, that it is so small that the drive frequency of this power supply must be pretty high. We have a small housekeeping power supply, maybe, I'm not sure if it's gate drive transformer, probably housekeeping supply. And on the output we have a little bit of capacitance, actually not that much. So the regulation must be pretty straight and stiff in order to have so little output capacitance. The controller board up here with the 10 megahertz crystal, not easy to see what kind of controller sits down there, but that's actually also a small pot meter for adjusting the output voltage perhaps. And it has another controller down here for the PFC stage. So it seems to be a modular design where they can actually switch out these controller boards. Taking a closer peek at the control pins, it has some wires that goes through here. Normally you would see that these would just bridge over between two of them in order to make a power supply run. But looking at these wires, it's actually, as you can see, this one out here goes out to the side. But looking at the other side here, it actually has a wire going straight out. So these pins do not seem to be parallel. Whereas the output pins and the input mains voltage, they are actually parallel when measuring through them. Okay, so all I'm doing now is measuring the output voltage, 230 volt AC in, and let's just see what happens once we power it up. .2 volt DC out, no fan running. Okay, it did have an LED at the front. It just has to remember this is a live circuit, so only touch plastic parts. Okay, there seems to be an LED blinking there. Let's check out the signal pins, and it would be best to find some kind of signal voltage. So if we check this up against the negative lead, so we have 0 volt DC there, 0.5, 3.6, and 3 volt DC. Now, in order to experiment with this without going through a complete circuit analysis, is to actually use some kind of a resistor. Here I just use a 1 kilo ohm power resistor. So if we just short circuit that across something like 3 volts or 5 volts or 12 volts, it's actually not pulling that much current. So we should not destroy anything. And if we should destroy it, we can also move up in resistance, go up to 10 kilo ohm. But the higher you go, maybe you have some circuits that won't react if the resistance is too high. So let's see what the control pins on the other side says in respect to the ground. So this is where we had 3.3 volts before, 3.5. Oh. So it starts acting up a bit weird when I try to measure a DC voltage between that. That's kind of strange. Should not have any input logic that would react to a voltage measurement. So see if we try that out with the resistance instead. And nothing happens there. So we can try the other side again. See if we can find something where we can pull it to ground. Nope. Then we can try between the pins, and nothing on that side. And you can say this is one of the quickest ways to make a power supply run. Just trial and error. Okay, no results there. Now I did mention that the wires seemed to make it possible that this was mounted, or it could be that it has to bridge over these two sides. And it has nothing to do with the server actually giving the power supply any information back. So let's just first put on, forgot the leads before, which actually is quite stupid, so I relied on fan spin. So we can see we still have 0.2 volts out, and if we then try to short circuit it from one side to the other through 1 kilo ohm, nothing there, nothing there, nothing there. Whoa! Bingo! Full output voltage and full fan spin. So that was the bridging over the last pair up against the main supply through 1 kilo ohm, makes it run at full speed. So I guess now we just have to bridge that over, maybe through a switch, and then do some load testing. So until next time, see ya.